Are we showing now?
Yes.
Cool. So when we had our initial discussions about this, can't see. That's better. It's fine. Okay, so we had our initial discussions about this animation, and many of you began talking about rectangles. So when you looked at that, did you see rectangles? Or it reminded you of rectangles? It reminded you, okay. And so this kind of underscores this idea that how calculus is typically taught is about summing up rectangles. When I was trying to show you that what we use this for is, given a rate function, this step function is trying to approximate that rate in order to do what? Why did we want to approximate the rate? Remember what it did for us? That was from last Wednesday.
Yeah. So if you approximate the distance or whatever the rate is affecting.
Right, so if this is the rate of change of distance, then given a constant rate, we could calculate a little bit of distance, right? And that was the purpose of doing that. Okay, and so this calculus course that Dr. Thompson has designed, that I've been teaching, and that we're working on developing this curriculum, is really about meanings, right? So meaning of integral is about accumulation rather than about area, and that's a foreign idea to a lot of people. Okay, so let's kind of step back. I want to do a lesson from much earlier in the calculus course. Somewhere here. Okay, and so talking about the idea of a piecewise linear function. Okay, so if a function has a constant rate of change and has different constant rates of change over different intervals, this would be a way to define a piecewise linear function. Okay, and remember we did the piecewise generator, right? The generalized piecewise generator. Remember that project? Okay. So this function, this line here, has a constant rate of change. What is the constant rate of change that is represented by this function? Okay. Carter wants 2. Kyle, do you agree with that? So how do you see that it has a rate of change of 2, Kyle?
It goes from -1, -1 to 0, 1.
Okay.
So that means it has to rise by 2 for every 1 exponent level.
Okay. So how could we represent that in the graph? How could I show a representation of that, the rate of change being 2 on the graph?
2 points.
So how about the 2 that he chose? Like this one? Okay. And what, Maria? So how can I represent constant rate of change of 2?
Well, you want to take the difference of the y values and the difference in the x values.
And how can I show the difference of the y values?
Drawing like the line of change in the y.
Yeah, change in y. Oh, not great. Let's try it again. I can do better. All right, so you're saying show the change in y. And?
And the change in x.
Really bad, sorry. Okay, better. Is this a representation of the rate of change being 2? That for any change in x, the change in y is twice that change in x. Okay. So what's another way that we can represent a rate of change of 2? What's another way we could graph a rate of change of 2? Any ideas? Are these y values? Are these rate of change? 2, 3, 4. Could we graph and have the y value be the rate of change? And how would we show a rate of change of 2 with an output that is our rate of change? What's that, Kathy?
I'm just thinking about Mon Oct to derive one if you're using the change in the value in y.
Okay, other ideas? If we graph the rate of change, so if we graphed on our vertical axis instead of being y values was the rate of change. And how would we graph a constant rate of change of 2? Carter?
Horizontal line y equals 2.
You want this horizontal line at y equals 2. With that? So both of these are there's two different representations of a constant rate of change of 2. On the left, the vertical axis is the value of the rate of change. On the right, that vertical axis is this quantity that's changing. So in both cases, so for a delta x, you're showing that it's constantly 2. Same constant rate of change over every interval of length delta x. And then over here, we're showing the same thing, just in a different way. Same constant rate of change over every interval of length delta x. Yeah, question?
Is that from the GC?
Yeah, this is so this is a GC animation embedded into a PowerPoint.
Oh, I didn't know you could do that.
Yeah. Okay, so here's a rate of change function. It's a rate of change of -1 for x less than 0, and a rate of change of 1 for x greater than or equal to 0. And what I want you to do is I want you to sketch the function f. So what would, over on the right side, what would the function f, the quantity that's changing, what would it look like for this rate of change graph? And I'm going to come around and look at your graph.
We know what it is. We know what it is.
Just sketch it. Just sketch it by hand.
The bar.
We're sketching what that looks like, or?
So, just like the last screen, we had the rate of change function on the left and the quantity function on the right. And they both showed a rate of change of 2. So now this is the rate of change graph, just like the one on the left before. Now you're sketching the quantity function.
Oh,
Okay. Now you're sketching the quantity function.
Is to find out my difference. Yeah, as long as you have it defined now. If you didn't have it defined, then you have to go into.
Which one?
I would say it could be either one because either way you have -1, but it just doesn't matter as long as it starts somewhere here because
Or
your
each.
x is 0 is where it changes.
You agree with that?
If you did say 3 days, this could definitely be a.
Okay, so lots of you have drawn this. Okay, any comments? So less than 0, rate of change of -1 means for every change in x, the change in y, how does it compare? Equal and opposite, right? Equal and opposite, that's the rate of change of -1. And then same thing for if the rate of change is 1, for every change in x, the change in y is?
But it doesn't have to start at 0, 0, right?
Does it have to start at 0, 0? So are you saying there's more than one possibility? Yeah, this is just one, right? Did anyone have it split like that? You can even have it. You don't have. It doesn't have to be the same quantity when you split when you change rates. You see that? There's another one. So many possibilities. Okay, again, the idea of a quantity function and the rate function both showing the same constant rate profile. Both showing the same constant rate profile as a rate of change output and as the quantity output. Okay? Tax table. Tax table. Okay, so how do you use this table to compute your tax? Most of you are single, and suppose you make 26.
That's being generous.
All right, let's go crazy here. Suppose you make 26,720. How would you find your tax? 26,720. What's the tax due on 26,720 for a single?
35.
Where are you looking, Rochelle? Show me where you're looking.
Between 26,700 and 26,700.
Right here?
Yep.
So we're in this range right here.
Yep.
And it tells us that our tax is this much.
Yep.
3590. Where does the table come from? Does anyone know how they've structured the way that we get, so given that number 26,720, how it's structured in order to calculate that amount of tax that's due?
By percentages.
By percentages. What's that?
You make it up.
Okay, but they make it up, and then what is it made up of? Yeah, that's right, and then what is it made up of?
Well, isn't it made up of a whole bunch of different steps? So if you're in this bracket, you're going to be paying this much, and then
Okay.
if you're in the next bracket, you're going to be paying a little bit more
Okay.
than the previous bracket. So it's all
So have
just
you heard of the different brackets, right? So our tax system is a progressive tax system. Okay, a progressive tax system. So let's take a look at that. Okay, so this is the progressive tax rate system. So let's first talk about the input and output of this function. What is the input into this function? What does X represent?
the income,
Maria?
your annual income.
Annual income. Agree with that, Richard? Is that what you're going to say?
Yes.
So it's actually, so we'll be a little more specific, taxable income. So from your annual income, there's some things that are not taxable, right? Deductions, right? You get to deduct certain amounts of your income that's not taxable, and we get down to this amount that's taxable income. Okay? And then what is the output of this function? Victoria?
The output is. Wait, you were saying X is the taxable income?
Yeah, the
And
input
the
is.
output would be the tax rate.
Yeah, so it's the rate. So here's the question. The tax rate, so the output is a tax rate. Is it the tax rate on
On the taxable income.
on all of your taxable income, on all the dollars that you made that year? Agree with that? Okay, let's actually walk this out. So suppose you make $100,000 in a year. Doesn't sound too bad. How do you make that money? Do you get to December 31st and all of a sudden you got 100,000? How do you make the money?
The gradual pieces.
Yeah, little by little, right? So what happens is there's going to be some amount of time that's going to take you to get up to this first amount, 8370, and maybe that's in, what is that, 1/10 of the year? So maybe that's in February. Okay, so sometime in February you're going to hit 8,370. What percent do you pay on those $8,370? You pay 10% on that amount. You don't pay, so 100,000, where's 100,000? In this bracket, right?
Yeah.
You don't pay 28% on that first percent of your income that you make up to that point. All right, and then we hit 34,000. It's about a third of the year. What's that? May? April? Sometime April? We're going to hit 34,000. And how much tax do we pay on those dollars? 15%. And then we get to 82. That's something in probably November or October. And on those dollars, we pay 25%. And then on these dollars, we pay 28%. So what is the output of this function? We want to be more specific. Yeah, it's the tax rate. But what tax rate is it? The output of this function. Anna, what do you think? So the output is the tax rate on all the dollars that you make all year?
No, it's the dollars in the intervals that they're in, so like from, I don't know how to explain it.
Okay, Daniel.
The tax rate on your current output?
Current, what do you mean current output?
Your current taxable income.
Right, so it's on the last, what? It's the last dollar that you make. You see? So it's on so this is talking about, so if your taxable income is 100,000, it's talking about that $100,000 that you made, it's the tax rate on that dollar. Okay? Because of how this works, right? How this works is that first 8,000 you pay 10%. The next up to 34,000 you pay 15%. Okay. How can is the tax rate, these numbers, this tax rate, is it a rate of change? And if so, it's the rate of change of what quantity with respect to what other quantity? If it's a rate of change, then it's the rate of change of one quantity with respect to another. So is it a rate of change? And if so, how? Michelle?
Wouldn't it be the rate of change of your income in relation to how much you're paying in taxes?
Okay, so
Or, I mean, yeah.
okay. Jackie, what do you think?
Not
Sure.
I almost said
Yeah, Daniel?
I think it might have been just the other way around.
Okay.
Would be the rate of change of the tax money you pay in respect to your taxable income.
Grant? So if a rate of change is generally what? Delta y over delta x, we're saying that it's the rate of change of Daniel?
The taxes you pay
Tax you pay
with respect to your taxable income.
with respect to taxable income. What do you think?
Yeah.
Yeah, so it's a rate. So it's a rate of change. It's tax you pay with respect to taxable income. Questions, comments? Does it make sense so far? Okay, so this function here is we looked at those graphs, right? Would it be like a graph on the left or like a graph on the right? Julie, do you agree with that? She said, Maria said graph on the left. What do you think?
I forgot which one's on the left, which one.
The left was showing our constant rates, right? And then the right showed the quantities. Or the,
So then,
remember.
which one are we talking about? I mean,
So this tax rate function.
the one where the
So
brackets is it?
So the last example we looked at is this, right? And then we said it could be maybe like this, right?
Yeah.
So this tax rate function, does it relate to a function like that?
Yeah.
Or like left or right?
Left.
Left. Okay, right. Left. Correct. Left. Okay. Questions on this? Okay. Here's another function. So I want you to discuss what's the input and output of this. So you study this function and tell me what's the input and the output of this function. Go. What's the input and output of this function? So make as many observations as you can about what you're seeing here.
The graph we did where we have.
I think the input's still something. The output's your actual taxes.
It is going to
What you're paying.
It's kind of like
But you pay the output here. Yeah. The input's what you have your taxable. All your taxable income is output what you're paying.
That's actually fits my
I don't know, but I think to save this function. Just keep the taxes.
Because if you fit into, if you still made $100,000, okay, 28% times how long we've been in that bracket, plus what we would have been if X was 82,400. So then you would do the same thing there. Just recursively calls it all the way up. Find out what you made while you're at 82.
Okay, sounds like it's winding down. Janae, what's the input into this function?
Input is anywhere between X and the number.
So what quantity does it represent? What quantity is our input?
X.
Yeah, what does X mean? What does X mean in this case?
How much you earn?
How much you earn? Let's see. Anna, you agree with that?
Well, we said, again, taxable income.
Taxable income. Yeah, so it's basically how much you earn less your deductions. So yeah, so taxable income, which is an amount that you earn. Okay, what do you think the output is? Jackie, what did you guys talk about?
I was more confused on the output and input. It's like the total tax that you would pay on them, because since it's like has X minus like 8,375,
Okay.
that would give you the times 0.15 would give you the tax you're paying just on that
Okay.
specific interval, and then the plus tax rate 8,375 is the tax you pay on up until then.
Okay,
For your total tax.
so total tax due on the taxable income. Agree? All right, cool. So what's the form of, so this is a piecewise function. So what do you notice about the form of each piece? What do you recognize anything about, say, if you just look at, say, this one line here. Richard, what do you recognize or
it
observe?
starts off from the previous value and connects to it and makes a section of a linear function.
Okay, he's saying it's a linear function that's starting off at the end of the previous interval. You get lots of nods there, Richard. Good, yeah. So, this is this is our, what is this? This is our point slope form, right? Remember our point slope form? This is our point slope form, which very conveniently allows us to jump off from where we were in the last line and start at the new rate. So let's break this down. And Jackie started to do this, but let's do one thing at a time here. What does that quantity represent right there? So X minus 82,400 as a quantity, as a final answer, how would you describe what that represents? Bennett?
The money does. It's your total income minus the 82,400 that has already been taxed.
And what does that give you? When you do that subtraction, what do you get?
The remaining taxable income in that bracket.
He's saying this is the taxable income in the current bracket. Matt likes it. Taxable income in current bracket, and this current bracket is 28%. What's another way you could talk about this amounts relative to 82,400? So that's talking about it relative to the percent owed. What about relative to 82,400? How could you talk about that, Rochelle?
Remember the change in X from 82,400?
Okay, and what would that change in X represent? Change.
Your taxable tax bracket.
Yeah, so it's your change in income since you made 82,400, right? So it's how much more you've made above 82,400, right? Okay, cool. So let's go to another one here. So let's change it to black. So I want you to now, right there, that whole thing. What does that? So plug in some value of X, and that whole thing is a quantity. It's a number. What does that number mean, Steve?
The amount of income that will be taxed after you made $34,000.
The amount of income taxed. So it's the amount of income taxed at the 25% rate. Raymond, agree with what Steve said?
Yes.
You agree? Daniel?
Yeah, I did differently in my mind.
Okay, it's the amount of income taxed at 25%. Carter?
Because it's times by the tax rate. It's no longer the amount of taxable income. It's the tax you pay in that bracket if you made more than that bracket.
So it's not a taxable income, it's an amount of tax that you pay. It is the tax. Steve, you want to change your mind?
Yeah.
And Raymond? Sit closer next time. Or coming up and sit closer. All right. So if X is our taxable income, so let's walk this through. If X is, say we make 50,000, what will 50,000 minus 34,000 represent? Is that amount of tax or amount of taxable income? That's our taxable income above 34,000, right? What would that be? 16,000, right? So now if we take that 16,000 and multiply it by 0.25, what did we just calculate, Raymond? Take that 16,000, which is how much taxable income we have, and multiply it by 0.25. What's that going to give us, Daniel?
So the taxes paid in that bracket.
Yeah, so it's the amount of tax you would owe in that bracket. Okay? And then finally, go back to blue. What does the whole thing together represent? Daniel.
The amount of tax we pay in that bracket plus the previous value of the total taxes due.
Okay, so it's the amount that you owe in this bracket in addition to
The previous amount we had to.
right. And what would that be when you add those two together? What would it be? Yeah. And what is so as one thing? What is that number? Kathy?
Your total tax due.
Total tax due, right? Total tax due. When you add all the previous accumulated tax, that's the total tax due. Okay, so in terms of delta language, what is this? X minus 82,400. And the delta X, right? So it's delta X. Okay, and what is 0.28? It's a rate. Let's call the tax rate K. And what is the whole thing? What is K times delta X? Isn't that the change? That's the change for this change of income. It's our change in tax due. Okay, and then what is? Yeah, that's the old accumulated, the previously accumulated. Y. And that's our point slope form, right? That no, sorry. So this much, sorry. If we're going to add y, it's no longer the change in y, right? So now we're going to take that k delta x, and we're going to add the previously accumulated y, in this case, tax due. And what's that going to give us? Total tax due, which is y. So the progressive tax table is an exceptional example of piecewise linear function, right? And how we can see the change in x, the change in y is the constant rate times the change in x, and your total y is change in y plus the previous y. Or the new y equals the change in y plus the old y. So this is a great example of piecewise linear function and use of the point slope form. Okay, any questions? Okay, so there's a series of questions here. So this is, I guess we're talking about Sarah here. So now we have the graphs that we talked about earlier. Okay, so it's the left and right graph similar to what we looked at earlier. And so where in this animation should you look to see Sarah's taxable income growing? Where in this animation should you look to see her taxable income growing? Maria? What about the one on the right?
Because as she works throughout the year, she gets more and more taxable income. So tax due increases in respect to her income.
Okay, maybe I'll give you a minute or two to just talk about everything you're seeing with people, and then we'll answer these questions. How about that? Let's get adjusted to what we're looking at. So talk to people at your table for about a minute or two, and then we'll go through these questions.
Look at the both graphs show the taxable income. That's the x. Left shows you it's just look at you.
Yeah, taxable.
Yes. Yeah, it shows exactly what her tax rate is. And the one on the right is more about how much she's paying. And you can still find the tax rate even on the right. It's just different to the scheme. You can see where it turns. But it almost looks like a jump. Oh yeah, that's right.
Okay, so now you've got time to watch it, think about it, and look at all the details. So, Maria, do you want to?
Yeah, I would say you want to look at the taxable income x-axis and see after a certain amount of taxable income she's getting, what rate she'll have to pay or how much she will have to pay. So I'd say in the animation you look at the x-axis.
Look at the x-axis of which graph?
Of both.
Of both graphs. What do you think? She's saying the x-axis of both graphs. What was our x quantity in the previous functions? Our input quantity? Taxable income, right? So that we're showing that quantity growing along the x-axis on both graphs. Good. Okay. Next question. Where should you look to see Sarah's marginal tax rate for the current value of her taxable income? Jessica.
I look on the y-axis and the one on the left labeled marginal tax.
She wants to look at the y value on the left graph. Agreed? Mm-hmm. Yep, that's showing the rate for the current value of taxable income. Where in the animation should you look to see the amount of tax that she owes for the current value of her taxable income? Anna. So where'd you look to see the amount that she owes for the current value of her taxable income?
So the right graph on
The y value of the right graph. Cool. What does the current value of her taxable income mean if that amount continually changes? So how can we have an image of a current amount of taxable income? We've used this language in the last two questions. Let's step back and say, what is the current value? So what would you say, Matt? What does the current value of our taxable income, quote unquote, mean if that amount is continually changing?
Yeah, we have a constant rate of change. I don't know.
So she's always making money throughout the year. So how can you define what the current value of her taxable income is? How can we make sense of that?
I mean,
Richard?
it means it's higher than it was before, and now
Okay.
now potentially she may be charged an increased tax rate, and she's paying more taxes.
So it sounds more like you're talking about it increasing.
Yeah.
Is that what it means by talking about the current value of her taxable income? Yeah, Ben.
I think it's just referring to a specific X value.
Okay. And what would we need to do to get a specific X value?
Well, we just have to have a start and end point, or an end point in this case,
Okay.
because she can only make so much in a year.
Okay.
So when she makes that amount, that is the current value of her taxable income, or some point in time, some other reference.
Okay.
Well,
Rochelle?
I was thinking more of like in a general term, like if you knew how much tax she paid, then you could figure out how much money she had at the beginning, or you could figure out like a range of income.
So it's kind of like you're working backwards.
Yeah,
Something like that.
Yeah.
Okay. Other ideas? So basically, we can just come along here and we can just pause life. We just pause life, right? And we say, if we pause life, then there's this certain amount of taxable income that she's gotten up to. Okay? So now we've paused life. What does a point on the right-hand graph represent? What does a point on the right? Julia, what does a point on the right-hand graph represent? So I'm actually go a little bit further forward. There we go. Okay. So this point, what does it represent?
When her current taxable income is about $38,000,
Okay.
$39,000, the tax due will be $6,000.
She said when her current amount of taxable income is $39,000, her tax due would be about $6,000. Right. So a point is two pieces of information associated to one another, right? Two pieces of information associated. Okay. Point on the left graph. Victoria.
So when her taxable income is, it would be 39K.
Okay.
They both represent the same X value.
Right.
Her taxable, or the tax that she would pay for that 39K is 0.28.
This is, I think this one's 0.2. Yeah. So the tax that she pays on $39,000 is at a rate of 0.25. What do you think about that? All 39,000?
No.
So which amount of money?
Which is what's above the 32,000.
Yeah, it's just for the current dollar, right? This is the current dollar that she's making, the tax that she pays on the current dollar or the next dollar. Okay, why does the marginal tax rate jump discontinuously? Carter.
Because as somebody reaches a new bracket of taxable income, they pay a higher marginal tax rate. And it's not a constant change into it. It's as soon as you hit this certain amount of dollars, all of a sudden you're paying a higher rate.
Yeah, you're the 9,000. Is that what did we say that was?
8,370.
837. So that the $8,369 you pay which rate? 10%. And then on the $8,370, well, maybe $70th dollar, that you're still paying that. The $8,371st dollar, suddenly you pay 15% on that. So there's a jump because there comes a point where on the next dollar you're suddenly charged a higher rate. Okay, why does the graph of tax due versus taxable income change slope abruptly? Richard. So can you see that?
Yeah.
Right here, there's an abrupt change, and right here, there's an abrupt change.
Just because we're changing the constant rate of the constant tax rate. That's why there's a break like that. It's not a continuous change.
Okay. Right, so there's an abrupt change that reflects the abrupt change in rate. That's right. Okay, in what way does Sarah's tax due accumulate? How is this reflected in the graphs? In what way does the tax due accumulate? Does it accumulate, the tax due? Or is it all of a sudden, just one day, the tax man comes and says, you owe this. So how does it accumulate?
The more her taxable income increases,
Okay.
the more her taxes due is going to increase.
Okay. So, how do things accumulate? So when you clean your apartment, right, then you come home the next day, and there's an inch of dust everywhere in your apartment, or wherever you live. Is that right?
No, it's gradual.
Right, it's gradual, right? Like, so little bit by bit, the dust accumulates so that if you don't dust for a year and a half, then you start to see, right? And so this is the same thing. We can look at a little change in income, call it delta X, and for that little change in income, when she makes a little bit more, what happens?
She is taxed a little bit more.
Yes, the amount that she's taxed goes up a little bit. So on 39,000, if we talk about the tax on every dollar earned, we're adding up the sum total of 39,000 little bits of tax due for each dollar earned. So this is a way to think of that tax due accumulating.
Would you rather say the same thing over a change in X that goes from one tax bracket to the next step? Like,
So right, that would be problematic.
right, so that's not going to follow the same gradual as all previous gradual.
That's right, and so that's why I'm breaking it down dollar by dollar, because that wouldn't be an issue then, right? Because we get to the last dollar in this bracket, we'll pay a certain rate, certain portion of it. The next one, now yep, you got, so your new amount due on that next dollar will be higher based on the new rate. So you're right, if you take a delta X across one of those jumps will be problematic.
Right.
Okay, so your focus for Wednesday is your proposal. If you have time to keep working on the stuff from left, feel free, but we want to do our best that we can on the proposal, have that ready for Wednesday. Okay? See you then.
See you later.
Okay, I have a quick question as far as like,
Oh, I get it. I already got on.